Okay. So, dimensional analysis. Whoops, I can spell. Okay, which is just oh my god, I did it again. Okay, there it is. Yes. Yes. Which is just a fancy way of saying problem solving, right? Dimension meaning we're looking at the units, right? And analysis meaning we're problem solving. I have, of course it's on 2 pages, a little area in that 1.1 section about problem solving. So I want to go through and solve all of our problems systematically so that we can get a feel for the process and how to practice it, right? So whenever we're looking at problem solving, the first thing we always want to do is ask, what is the problem asking us for? Meaning, what are the units that we want the answer to be in, right? Everybody with me on that?
Yeah.
Cool. The second thing we want to do is figure out what information is given in the problem. So especially with word problems, there's often information that's given in words that we can translate into units or mathematical symbols, right? And I think this is one of the areas that that students tend to struggle with, right? So we're going to demystify that a little bit. The next step would be to see if you can arrange the pieces you are given systematically to cancel all of the units except for the ones that you want in the answer, right? So that's the dimension part, right? We're setting up the units to cancel. Whatever we don't want, we cancel out. Whatever we do want should be left over in the numerator when we're finished. If you think you're missing a piece, so if you set things up and you get stuck, right? Maybe you get to a certain unit and you're like, I don't feel like I have the unit to cancel this, right? Always go back to the question, because oftentimes you may have overlooked a piece of information that you didn't think was relevant, but is actually relevant in this case, right? Does that make sense so far, you guys? Cool. And then last, does the answer you got make sense, right? So if you started out with a very large number, right, and you get a very small number, does that answer make sense in the context of the problem, right? Now this part is the hardest part, right, because it's really difficult to have intuition about whether or not your answer is correct. But this is one of the things that I really want us to try and develop when we're doing dimensional analysis, is always thinking about, does the answer that we got make sense? If it does, how do we justify it? And if it doesn't, is there something we did wrong, right? So those are the steps we're going to go through in problem solving. I am going to start off on this, whoops. Sorry, I'm pulling up the worksheet on my end. I am going to start off by doing some dimensional analysis problems, and then we can go through some different problem types. So I'm starting off with number 3A from our worksheet, which has what volume of sulfuric acid solution, I'm abbreviating solution because I'm too lazy to write it out, would weigh 12.5 kilograms. The density of the solution is 1.63 grams per milliliter. That's a question. Okay, so what's our first step?
Would it be to write down what we know? So we have 12.5 kilograms.
That's our second step, and we're going to do that definitely. But most important of all is figuring out what the heck we're trying to solve for, right? If you don't know where you're trying to go, you are not going to get there, right? So in this particular problem, what unit are we looking for?
Grams over milliliters.
Is that what the problem's asking us to solve for?
Oh, kilograms?
Roxana, did you have it? I can't hear you. Oh. So let's read through the problem together again. What volume of sulfuric acid solution would weigh 12.5 kilograms? The density of the solution is 1.63 grams per milliliter.
So we're looking for a volume.
Exactly, right?
Okay.
Does everybody see how the problem is asking us to solve for a volume?
Yeah.
Cool. So, if we're looking, so we know we're looking to solve for a volume, right? What kind of units could a volume come in? So what are some of the different flavors of volume?
Milliliters.
Milliliters, right? Liters, cubic centimeters, any of those would be possibilities, right? Does that kind of make sense for everybody?
Mm-hmm.
Cool. So now we're going to do, as Angelique was saying, we're going to put our information down, right? Make sure that it's all written in a form that is easy to understand. I'm sorry you guys get to deal with my message feed. So we have 12.5 kilograms. Now, excuse me, of solution, right? Do I need to write that part down? Maybe not. It might not be important, but you never know when information is going to be unimportant until you start getting into setting up those pieces to cancel each other out, right? So I would argue that writing out a description of who everything belongs to is super helpful in terms of making sure that you've identified the units and who they belong to appropriately. Questions about that? Does that make sense, guys?
Yeah.
Cool. Okay, so this is the mass of the solution, right? And then we're also given the density of the solution, which is 1.63 grams of solution per 1 milliliter of solution, right? Where did I get that 1 from?
Is it implied?
It is implied, yeah. So when we look at the unit grams per milliliter, we don't usually write 1 milliliter, but it's implicit, right? That 1 is there, we can choose to put it or not put it there, right? I think for dimensional analysis purposes, it helps to write the 1 in because when we set up the units to cancel, it just makes it look a little friendlier, right? So what's our next step?
solution map?
Yeah, basically, what I think is helpful is before we even get started with the units and canceling them, I think it's nice for us to make a map of where we're trying to go, right? So if we know that we're trying to get to a volume, right, then my end game over here is going to be a volume. Now, what unit do I have in all of my information that could be considered a volume?
Milliliters.
Milliliters. Is everybody comfortable with that?
Yep.
Awesome. Cool. So we know that we're trying to get milliliters by itself. Right? So I know that milliliters is in my density, right? So I know that I'm going to need to use the density. Specifically, I'm going to need to have milliliters on top, right? And I'm going to need to have grams on the bottom, right? Because if I want this volume to end up being in milliliters, not 1 over milliliters, but milliliters, right? Then I need to invert this density. Does that make sense, guys? Kind of, sort of? Cool. But I know either way, I'm using the density here, right? From the density, I want to cancel out the mass, right? So I'm going to need to use the mass that I'm given of the solution, right? So this gives me an idea of how to map the railroad tracks that I'm about to set up, okay? So I'm going to start off with 12.5 kilograms. I'm going to lay down my railroad tracks. I like to, usually I'll end up having to erase this step, but write down the units. Oh, I'm lagging good, huh? You guys see that? Oh no, cool, you can. So I like to write down the units of where I'm trying to go just to make it easier to visualize that that's the answer, that's the unit that I'm trying to end up with, right? So going from mass to density, right? Is that a straight shot? Can I use kilograms to cancel grams?
No, but you can convert the kilograms to grams easily.
Is everybody comfortable with that? So if we want to cancel out the grams that are in density, that's our eventual goal, then we need to get kilograms into grams first, right? So we want kilograms to grams here. So what unit do we want on bottom if we're trying to cancel kilograms? Excuse me. Kilograms, exactly. What unit do we want on top? Grams. So this is the part that's usually tricky for people, right? Are kilograms bigger or smaller than grams?
Smaller.
Mm-hmm.
Bigger.
Bigger. So kilograms are, this is a really stupid analogy, guys, but I don't know why it works for me. So I think about this in terms of shoe sizes. So kilograms is a really big shoe, right? And so because it's a really big shoe, a lot of grams can fit into it. A lot of feet can fit into it. It's a very stupid analogy. I don't know why. Visually, it just works for me. So if I know that kilograms are big, then I know that a lot of grams are going to be required to fit in there, right? So 1 goes down below, and 1,000 goes up top. Does that make sense, guys?
So for every 1 kilogram, there's going to be 1,000 grams?
Exactly. Yes. Is it the stupidest analogy you've ever heard? Like people put multiple
I like
feet
it.
into.
It makes sense.
It's just it's a visual. The visual aid. I'm sure that there's a much better analogy, but I haven't. That one's just stupid enough to remember. I don't know why. Okay, so that'll cancel our kilograms, right? Now we are in units of grams. So if we want to cancel units of grams, what units do we need down below here?
Grams.
Grams, exactly. And our other piece of information has grams here and milliliters attached to it, right? So we can't separate these two units. They're part of the density. So what unit is going to go up top here?
The 1 milliliter.
Mm-hmm. Exactly. So we have 1 milliliter for every 1.63 grams of the solution, right? So grams will cancel with grams. So we're left with units of milliliters, right? Which is what we were trying to solve for. Does that make sense, guys?
I'm just a bit lost.
Okay.
So, how did you get from kilograms to grams? Like, how did you know, like, oh, okay, I need to turn kilograms into grams? Is kilograms always gonna convert into grams, or can it convert into something else?
It can convert into a lot of things, right? But we know that if we start out with kilograms and we're trying to cancel grams, right? That an easy way to get from kilograms to grams is to do a conversion.
Okay.
Does that make sense?
Yeah.
So it's really thinking about what units you have in all of your information and how you can set them up to cancel out to get the unit that you want by itself. Does that make sense, Yvonne?
Yeah.
Any other questions about this?
It turned around when I do 1,000 grams over 1 kilogram.
Yeah.
For some reason, I do it opposite. So I'll do 1 gram over 1,000 kilograms.
Yes.
That's when I set it up at home.
And that's a super common mistake for people to make is they invert the 1,000 and the 1, right? Which is where my idiotic analogy, hopefully, maybe, will come in handy for you guys. Kilograms or kilo of anything is always going to be much bigger than the base unit, right? So if you know that this guy is big, it means that a lot of these little guys can fit inside of it.
Okay,
right?
Thank you.
So again, I think memorization in terms of these things is really easy to mess up because these relationships are so straightforward. If you're just coasting with it, it's really easy to make a mistake, right? So really thinking about each one of these steps and whether or not they make sense is important to getting this technique down, right? Eventually, once you've done enough of this problem solving, you can coast with it, right? But for now, really thinking about, okay, what is the size of a kilogram relative to a gram, right? That's an important factor.
Okay, thank you.
Yeah. Any other questions?
So, okay, say for example, if the tables were turned and we're looking for grams, can it still work? Like, can we put like, okay, 12.5 grams times the 1 gram and the 1,000 in the bottom? Or can like the fractions switch?
So, if I think what I'm getting that you're asking is if we just wanted to know how many grams of solution we had?
Yeah.
Yeah, so then we would just do everything here, right? We wouldn't have that last step. It wouldn't be necessary.
Oh, okay.
Right?
Yeah.
So instead of canceling the grams, we'd stop at that step.
Okay.
Yeah. These are all great questions. Anyone else have any questions? We're okay?
Yes.
Cool. So now we want to solve for this, right? So I think it's easier before you put this in your calculator to kind of simplify this, get all the units out of the way. So realistically, what I'm going to put in my calculator, I'll try and write it kind of small down here, is 12.5, 12.5 times 1,000, right? If I multiply by 1, I get the same thing, so I don't really need to do anything with that. And then divided by 1.63, right? You guys are going to have to be my calculators. I don't know where my calculator is. It's somewhere in the room. My daughter likes to pretend like it's a phone. Pushing buttons. Do 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 do. Hi, how's it going? Hi, Nana. It's good.
I got.
Go ahead.
Okay, I got 7,668.711.
766.
8.71. Did anyone else get that?
I got that too.
Okay, cool. I want to make sure I'm not completely.
No worries. I like having you guys crowdsource the answers anyways, because it does two things. It allows you to see if you know how to calculate them, but also gets a couple of other people involved in case you accidentally press a wrong button somewhere. Cool. So this is our answer, right? We started off with 12.5 kilograms of solution. Is that a lot of solution?
Yes.
Yeah, right? That's a ton of solution. So we don't have a whole lot of experience with these metric units, but the average human being weighs about 70 kilograms. I'm sure I weigh probably closer to 90, but don't tell me, I don't want to know. But that's the kind of scale that we're looking at, right? So this is about a fifth of a person worth of sulfuric acid, right? That's a lot. So we expect that the volume that's going to occupy is going to be large, right? So getting a number that's in the thousands, that makes sense. You guys tracking with me there?
Yes.
Yeah.
Cool. So now let's take this answer and put it into scientific notation, right? So I have my decimal place out here. Now, some of you guys may be wondering, like, do I have to do this? And the answer is not always, but a lot of the problems that I'm going to ask you guys, especially in the short term, I'm going to be asking you to use scientific notation in your answers because I want you to practice it. So, yes is the answer, basically. Might as well practice. So we go 1, 2, 3 decimal places over here, right? And now I'm going to round this digit so that I have 2 decimals here. So 8 is going to round up or down? Up, exactly. So I'm going to have 7.67, right, times 10 to the 3 milliliters. Sweet baby doesn't want to do math right now.
Sorry, I keep trying to mute and then unmute when she's...
No worries, it's all good. Any questions about that, guys? Confusion?
Can you go over the scientific notation again? I'm sorry.
Yeah, absolutely. So we're going to do more practice with that. But before we get more into that, is everybody okay with how we solved this problem?
Yes, so I just have one question.
Yes.
Are you always going to want it 2 decimal places for proper scientific notation if it's like 7.666? Like,
Yeah, so it just makes it a lot easier for the Canvas grading if we systematize the scientific notation to just be proper scientific notation with 2 decimals rounded. Does that make sense?
yeah.
But if I want something different, or if I if I don't care what the answer looks like, then I'll always say that, right? So I'm pretty explicit in writing the problems and telling you this is what I want your answer to look like, or this is the form of the answer that I want you to have. Does that make sense, guys?
Yes.
Cool. Questions?
Can we do number 2D?
Oh my gosh, we're gonna do so many more. But what I want to do first is I'm gonna pause the video here,